Welcome back to your learning, everyone, and we are carrying on looking at geometric sequences now. If we go back up to the top here, we'll see we've already seen one example of a geometric sequence, and it's this one. If we take 3 and multiply it by 2, we get 6. If we take a 6 and multiply it by 2, we get 12. And hold on one here. Sure. It's the same as ours. Huh? Oh, what's your name? The name on your Google account. Jeez, what? Why? Oh, is this Miles's?
No, that's yours.
Oh, well, that's strange. Oh, geez. Sorry, everyone. Let me pause this video. I need to get my kid's Chromebook is all funky. Oh, yeah, we've got time. Okay, I'll do this later. Okay, very good. Okay. All right. This is distance learning, everyone, and it's confusing for parents as well. Okay, so we notice we're multiplying by 2 every time. And so how would we create a general term so that we could find the 10th term or the 100th term? Let's take a look. The hint is we've already explored exponential functions as a class. So these geometric sequences, when we graph them, see, this looks an awful lot like an exponential function. We have a growth factor here, which is being raised to a power, and I always put brackets around this because I don't want to think that that minus 1 is down here on this line. That would be a C transformation. That would be subtracting from my outputs of my function. But no, it's not that. It's a D transformation. It's subtracting from inputs. The N is the input. Okay, so always put brackets here, but it's an exponential function, right? We have an initial value, which is the first term, and we have a common ratio here that we're going to be raising to progressively larger powers of n. Now, these will graph to exponential functions, but just like their arithmetic counterparts, they will not be smooth curves, but they will be series of points that grow like exponentials, but they're a series of disconnected points. They're discrete. So that's our general term formula. Let's see how we apply it to study some of these geometric sequences. So we want to be able to solve for the first term, which is very easy. You just say, okay, here is our geometric sequence. And I'm going to say, well, A is equal to 4, all right? And then I solve for R. The way I solve for R is I want to find the ratio between these terms. So the way I can do that is I can take, say, the second term and divide it by the first term. And if that equals the third term divided by the second term, or indeed any term divided by the one that came before it, okay, then you have a geometric sequence. If this is true, then it's a geometric sequence. If you can show that they all have the same common ratio, that's what I'm showing you there. So let's do some of that math and we'll check, okay? So if we check T3 divided by T2, well, that would be 36 divided by 12. And that's equal to 3. But if we did T2 divided by T1, well, that's equal to 12 divided by 4, which is also equal to 3. Okay, so since 3 is equal to 12 divided by 4, which is any one of the terms divided by any one of the previous terms, then 3 equals the common ratio. Okay, 3 equals R. All right, so we have our R is equal to 3. These are the two numbers that we need to build the general term for a geometric sequence. So they look like this. The nth term of this sequence is going to be equal to, well, I'm going to write out the general formula. It's going to be A multiplied by R raised to the power n minus 1. And put brackets in this way, and it's very, very clear. All right, so let's write out the, for this one, it's t to the n is equal to 4 multiplied by 3 raised to the power n minus 1. Okay, and now write out the next 4 terms it's asked us. So let's write out the first ones. Here's T1 is 4, 12, and we put commas in between if we're going to list these, 36, and we've been asked to list the upcoming, well, let's count them. This is 1, 2, 3, and then we want the 4th, 5th, 6th, and 7th terms, okay? And if we were to just keep multiplying by 3, we would get them all. 36 times 3 is 108. 108 times 3 is 324. 324 times 3 is 972. And 7 times 3, the trick that I use here to solve that one is I'm going to take 18, which is the difference between this and 1,000, multiply 18 by 3, which gives me, 18 times 3 is 54. And I'm going to take 54 away from 3,000. So 54, 3,000 minus 54, and that will give me 2,946. Okay, so that will be the 7th term, I predict. All right, maybe my arithmetic is wrong, so we'll see. So now let's see if we can use our general term to predict these as well. So I'm just going to check the 4th one and the 7th one. So let's use this formula here. The 4th term is going to be equal to 4 multiplied by 3 raised to the power 4 minus 1. Okay, 4 minus 1 is 3. 3 to the 3, so I'm going to write that out. T to the 4 is equal to 4 times 3 to the 3. Okay, 3 to the 3 is 27. 4 times 27 gives me 108. Hooray, we were at least right there. Okay, now let's check 7, okay? Now I'm just going to give myself a little more paper. All right, zoom in a little bit and use a different color. Okay, good, change colors, make this a little clearer. Let's try and find the 7th term here. T to the 7, sorry, not T to the 7. This is the 7th term. Don't say T to the 7. I don't know what I'm doing. T to the 7 is, the 7th term is 4 multiplied by 3 raised to the power 7 minus 1. Okay, the 7th term should be equal to 4 multiplied by 3 to the 6. Let's do 3 to the 6 on a calculator. Sure, because I did the other one in my head. So, what's this? Clear. This was me making the video earlier. 3 raised to the power 6 equals 729 times 4 equals 2916. I made some arithmetic errors, didn't I? I did. Okay. 2946. And what did I have here? 2916. Okay, so I lost 30 somehow. I made a mistake by 30. Okay, so I could try and find my mistake here, but that's not fun for anyone to watch me fix myself. So this is 2916. Okay, so that will be correct. This, I made some arithmetic error there. Multiplying that by, well, that's not 18 difference. That's 28 difference. That's why I should multiply 28 by 3. And that's where the 30 in my mistake came from. So I was actually pretty quick to find my error. It's a subtraction error. Okay, let's keep going. If I want to solve for the nth term here, and I want to find the 15th term, I don't know why they have 32 down there. Okay, that should be 15. I just noticed that. 1, 5. Okay, so let's say we want to find the 15th term of this sequence. Well, first we want to find, some of you might be saying, this is just powers of 2, but this is 2 to the 0. This is 2 to the 1. This is 2 to the 2. This is 2 to the 3, and you're correct, okay? This is the 1st, 2nd, 3rd, 4th term. What is our general term? T to the n, the nth term, the general term is equal to our starting value, a. So a here is 1, and our common ratio is 2, okay? If I divide 8 by 4, that's 2. If I divide 4 by 2, that's 2. If I divide 2 by 1, that's 2, okay? Because the ratio is common everywhere, therefore this is a geometric sequence. That's how you prove it. That's how you recognize it when you see these common ratios. Okay, so because a is 1, I'm not going to write it down. And I can just have, because a is 1, so I'm going to multiply by 1 here. Don't write it down. I'm 42 times 1 years old. Now, I write down the ratio here, 2, and then I raise that to the n minus 1, and then I've got it. This is my general term. Okay, notice that it works. If I put in 1 here, 1 minus 1 is 0, 2 to the 0 is 1. So that's great. Now let's find the 15th term. The 15th term of this sequence is going to be given by 2 raised to the power 15 minus 1. It's going to be 2 to the 14 is what I punch on my calculator. And that I don't have that memorized. But if I were a computer programmer and I worked a lot in binary, you'd be sure I would. So 2 to the 14 gives me 16384. That's going to be something I'm going to do. It's going to be a summer project. Memorize my powers of 2 up to like 20 or 100 or something. 16846. Okay, you can't even memorize it in 15 seconds since you 16384. Okay. 16384. So therefore, the 15th term of this sequence is 16384. Now, what if we wanted to know how many terms are here? Okay, let's see how we solve this. First, construct your general term out of this stuff. And you want to confirm that these do grow by a common ratio. So I notice that if I multiply by 3 here or I multiply by 3 here, that it's going to grow and follow that pattern. Perfect. A is the first term, 4. A ratio here is, what do I multiply by? 3. Notice these could also be fractions. You could be dividing by something, but we're not in this case. Okay, so here 4 times 3 is so then here I write my general term is going to be equal to 4 multiplied by 3 raised to the power n minus 1. Okay, so that's my general term. Now I want to know, what about this one here? So let's solve it. I know that at some point the sequence will be 2916, and I'm interested to know what number is that. This is the first term, second term, third term. This is the I don't know term. Okay, so let's find it out. This is going to be equal to 4 to the multiplied by 3 raised to the power n minus 1 for some value n, and I want to find this value n. Okay, so now Bedmesen. Okay, so my first Bedma step is going to be to get rid of this loose multiplication. So I'm going to divide both sides by 4. So 2916 divided by 4 is, use a calculator, 2916 divided by 4 equals 729. Okay, so 729 is going to be equal to 3 raised to the power n minus 1. And now you'll recognize this is a kind of exponential expression. And to solve, 729 is equal to 3 raised to the power n minus 1. What you do is you try and express both of these with a common base. Here the common base is 3. This is indeed a power of 3. So which power of 3? Well, I know that 3 to the 4 is going to be 81. Because 9 times 9 is 81, and 9 is 3 to the 2. So that's 3 to the 4. 81. 81 times 9 will give me this. So let's see. I am predicting that 3 to the 6 will give me, oh, there it is. Okay, so what I do is instead of writing 729, I write that as 3 to the 6 is equal to 3 to some n minus 1. Now, this must be equal to this because, well, these two things are the same. So I can write this without the base. 6 is equal to n minus 1. Add 1 to both sides. 7 equals n. Okay? Therefore, 2,000, or let's see the whole question here. We've been asked to find what the number of terms is. So, therefore, 2916 is the 7th term. So there are 7 terms in the sequence. Cool. Okay, so that's how you approach these types of questions, everyone. Any questions you got, you hit me up in the chat, or you ask me by email, or come on over here to this doc and drop your screenshot of your question or the page number and the question in there, and we will definitely talk about that tomorrow. How do I find that doc, Mr. Jennings? Oh, it's here in our Terrific Tuesday thing, and you can just click on there. Share questions to be taken up here for tomorrow. Okay, bye for now, everyone, and thank you for showing up for your learning.